me share the screen. So far, we have covered what to test in terms of test conditions. In that, we did boundary value analysis, then equivalence partition. Basically identifying the buckets or the bins or which category this test belongs to. There is a standard technique. Okay, there is a standard technique for negative testing. Very simple. Numeric field. If it is a numeric field, enter alphabet or punctuation marks, special characters. Other than comma and dot, the numeric field should not be accepting. Same way, if they say alpha, then enter number, punctuation mark, other characters. If it is alpha numeric field, like the Eisenstadt is an alpha numeric TN07CB, something like that. So it has got alphabets and numbers. Alphanumeric, enter special characters. So blindly we can train anybody to do this test. But the problem is lot of mistakes happen right here. Not every developer has done all the validations for the input fields. Always remember, if we take bad food, we will be affected. If we drink bad water, we will be affected. Same way, if software takes bad input, obviously it will be going wrong. So catching the input with correct values or valid values itself is biggest thing within software. Restrict the entry itself. If you catch right at the screen, it will not enter the server, it will not enter the database. So for negative testing, blindly you can put this. For numbers, put other characters. For alphabetic, try number, punctuation, and other characters. For alphanumeric, special characters, try. It should give a warning or error. System should not happily take and then your value is saved. It should not give such a message. This is a standard technique for negative testing. Blindly you can do. One of the biggest mistake people do in testing also, they know a lot of things, but you have to do for every field, give a wrong data, see if it works or not, whether it is rejected or not. So you have to do. Doing has got 95%, knowing has got only 5%. That we need to have, that mindset we need to have, but it is very difficult to change because many times people, oh, I come to a training, I just know. You have to apply. The next technique, we talked about CRUD, right? Create or new or insert, save a new record. When it comes to this, there are two standard conditions, test conditions you should always think of. For create operation, anything that you are adding new, add a brand new record. This is one condition. Add a duplicate record. Suppose you added one account number or one credit card number, you try to add the same credit card number. See what happens. You added one item with an item code, add the same item with the same item code. See what happens. So obviously, one is a positive test, one is a negative test. Second thing, read, right? Create, read, or view. In this test, try to view an existing record. For example, you know, in your college application, you know this roll number exists. What is the name of this roll number, or which grade or which department this roll number belongs to? You give a valid roll number, you have to see whether it displays the right information. Second thing, to view a non-existing record. Suppose roll number 4100 is existing, you know that, enter that, see whether it displays the right name. Suppose you know 4120 doesn't exist, enter 4120, system should say this roll number does not exist. So for read also, standard two tests. Same way for update or modify. Modify an existing record. For example, you know the roll number is existing 4100. For that roll number, you need to change only the CGPA. Instead of 8.2, you want to update it as 8.3 as an admin or as a faculty. So you give the roll number 41200, enter the valid, so it works. Again, try to modify with invalid values. Is that CGPA, you know, from 0 to 10. Roll number exists, but you go to that place in modification also, enter 11.2 as CGPA. See whether the modify works, because when you are adding a new record, the developer might have written a code. While inserting, the developer would have written the validation code. While modification, the developer would not have done that. You never know. So it is your responsibility. Whatever validations that are there for the fields, in modify also try to modify with invalid values. Again, another standard way. Delete an existing record. So you go and then this roll number I wrongly added, or this roll number no more exists in our database, delete it, not a problem. Same way, delete, cancel instead of confirming. Click and then it is gone. You're out. Unless it is a standard application with a lot of deletion that is happening. Whereas in most of the applications, it will always ask whether you want to delete, are you sure? In that point, you cancel no. See whether it is not deleted. That is also a test. So for every field, you do negative testing, for positive testing. For every operation, create, read, CRUD. Always in software, CRUD rules: create, read, update, delete. You can insert a new record, you can see a new existing record, you can update an existing record, you can delete an existing record. For each of these, do a test. This itself, in every screen, if you see add, modify, delete view, add, modify, delete view, if you cover 80 to 90% of the testing will be covered. Still, there will be some 10% left. How to cover the 10% also? Remember Kaushik's class, test coverage. That is also important. That is very important. How sure that the product is fully stable? Are you 100% sure that you can go home with peace? Otherwise, you go home, there will be tension. When the call will come from the office, your program is not working. Immediately, can you fix it? All those issues will come. And otherwise, if you are a tester, then they will ask, why didn't you test this part? It is a very trivial, simple test. You missed this very simple test. So they will always tell that. So to the extent possible, we should make testing as a science in a structured approach. This is how to write test scenarios, how to look at permutation combinations. Is this clear up to this point? Can you raise your hands or give a reaction? Is this clear up to this point? I'm waiting for your feedback. Different ways of thinking permutation combinations to test. Good. Many people raise the hands. Can you give at least one or two, give a reaction? I can at least understand. Okay. Responding. Good. The next step is, remember the three terms. I have been giving very specific terms. I think yesterday or day before yesterday's class, I was telling about user, activity, data. Remember that. These things should be remembered lifelong. Even after my teachers, my mentors taught me this, I still remember, I transfer the knowledge to you. These things do not change. These concepts do not change in software. Okay. Another standard questions, set of questions people ask me. Oh, I do not know. I am a tester of web applications. I do not know how to test mobile applications. For a tester, it doesn't matter. For a tester, it doesn't matter because this is also a screen. Mobile screen is also a screen. Here also you input. There also you give inputs. Here also you either click or type. There also you tap or type. As a user, remember, tester is always mimicking the customer, closer to the user. As long as the operations are same, you can test any technology, whereas that is not true for developer. If you are a Java developer, you cannot maintain the code in Node.js. If you are a SAP developer, you cannot do maintenance of a C++ code. So technology changes or the programming language changes, developer cannot shift from one project to another. Whereas a tester, it doesn't matter. It doesn't matter at all. Okay. So that's the advantage of testing. And since world is moving at a very fast rate, more software is coming. More complicated software is coming. So you need to find out bugs in the complicated software. So more testing is required. More software, more problems. And to unearth or to bring out all those problems, we need more and more testing. That is why testing is here to stay. Testing is also a very, very rewarding career. The next topic is test case. Remember the three terms. Already talked about activity, user, data. Okay. Next thing is test scenario, test case, test results, bug report. Okay. Again, these two go together. Okay. Test scenario, test case, test results. This is another standard three terms that you should remember in testing. And rather than three terms, I will say remember the following terms. Let me also put lifelong. Before that also I have given certain things. Configuration, security, functionality, performance, and then compatibility or environment. This I have told, remember. Next thing I told about what to test, how to test. Remember that. Then we talked about positive test, negative test. Remember. Then everything, activity, user and data. And also I talked about ask doubts. Read the requirements, understand and ask doubts. You should remember these things. Never you can forget these things. Okay. So far we have covered a test scenario is also known as test condition. Now there is a new term called test case. What is this test condition? What to test? What to test is what our test condition. Now, how to test? That is called test case. We need to think of what to test. We need to think of how to test. How to test is nothing but step-by-step instruction. Do you guys remember? I come back to the screen. Do you guys remember our chemistry lab or physics lab records? How many of you remember chemistry lab, physics lab records? Can you raise your hands if you remember or give some reaction? Good. I could see 6 or 7 hands raising. Good. What do you write in that? What do you write in the records about experiments? In each experiments, standard sections. What are those sections? Do you remember? Can you type it in the Q&A chat? Let me know. In a chemistry record, lab record, or a physics lab record, you will be writing something. What is that? It is the first section of each experiment. Aim, apparatus required, observation. In between apparatus required and then observation, there is one other section. Aim is correct. Apparatus required is the second section. Then after that, that and observation, there is one other thing. Even before aim, there is one thing. Experiment number. Okay. You have to give say experiment number 17 because there is a in your syllabus also there will be some number given. You have to use the same number. At least in our schools we followed. In our college also we followed that. In between apparatus required and observation, there is something. What is that? Do you remember? Anybody? There is a section. Procedure. How do you remember? You will be writing procedure. If you remember, give me a reaction. Or raise your hands. Yeah. That is where you will write, I will do this, I will do this. Create or say, make the solution. First take, clean the pipette, clean the burette, clean the conical flask using distilled water, dry the apparatus, make solution with 5 grams of the salt given, solute given, right? Add distilled water as a solvent, right? Move the flask like this, make the solution. Take 5 ml of that solution using pipette, drop it in another conical flask. What is the liquid that you will take for titration in the burette? Pipette is a small one, burette is the long one on the stand. In the burette, you will take some other liquid, some other chemical. What is that? What is the solution? Potassium permanganate solution usually, right? Add the solution in burette. Fill the burette till 90 ml mark or 100 ml mark. Note down the reading. So you will write step-by-step procedure. To find out what is the salt, the procedure is different. Take the salt, look at the color. Second thing, take the salt, put it on a moist litmus paper. See whether there is a color change in the litmus paper. Take the salt and then put it on take it on a stirring rod and a glass rod and then put it on the flame. See what is the color. This is the procedure for salt. For some other, the procedure will be different. For eye operation, cataract operation, the procedure is different. For kidney stone operation, it is different. For delivery, it is different. For heart surgery, the procedure is different. So The procedure is, before doing the surgery, the doctor will discuss with other fellow doctors and experts what procedure we should follow for this patient, because the same procedure may be 95% correct, but 5% for this patient is diabetic, this patient is having some other ear allergy, so we need to do this way. So there will be some very specific step for that patient. You cannot miss that step. That is why now let us come back to, I'll take an Excel sheet. Before Excel sheet, let us say lab experiments, aim, apparatus, then procedure, before aim, experiment ID and date, maybe procedure, observation, conclusion. This is what you do. This is same, but the procedure will keep different. Apparatus will be different. Same way. Now let me take you to one site. This will be very interesting to you. I'll show you one site. You'll be extremely thrilled. I don't know how many people have already seen this. These are all called simulations. These are all extremely good ways to teach. I am going to do a circuit, AC circuit in electrical engineering. Just keep watching. It will be very interesting. I click on these AC circuits. This is called a PHET, PHET interactive simulations by Colorado University. Extremely good ones. I am going to do an experiment. What is the experiment? Aim. Create a simple circuit with 2 cells in series connection. Aim is simple circuit with 2 cells connected in series connection. So apparatus required cell, apparatus required bulb, switch, connecting wire. Procedure: take one cell, take another cell, connect these two in series connection, positive to negative, connected in series connection. Take a wire, connect that to the negative end of the battery. One is cell, two is more than one is battery, right? That is a standard notation. Connect this wire, take a switch, connect this switch with the wire, take a light bulb, okay, connect one end of the switch with the bulb, connect one end of the wire with this battery positive, connect that other end with the switch. This is not video, this is just a simulation. Exactly, I'm mimicking a circuit. Circuit is ready. If I turn on the switch, what will happen? Anybody can answer? If I turn on the switch, what will happen? Anybody? Can you type it in the answer? I turn on the switch. Bulb should glow. See what happens. I'm going to turn on the switch. Ha! Battery is burning. And electrons are moving so fast. Why? This is short circuited because bulb has 2 points. One end should go to one end of the bulb, other thing should go to the other end of the bulb. In the battery lights, you could have seen that. This portion is connected to one end, there will be another knob connecting to the other end. Now I connect that way because I missed that step. In the procedure, I connected both the ends of the wire in the same way. That I should not have done. right? I just connect this portion here. I connect this portion here. Now I switch on the light. Now the bulb glows. Electrons are not, like short circuit, battery is not burning. Measure the voltage. Take the voltmeter, connect at the one end of the battery, connect on the other end of the battery. It is totally 18 volts. Now I switch off, bulb should stop, should stop glowing. Switch on, bulb should glow. It's interesting. If it is interesting to you, please raise your hands. This is simulation. Experiment you can do through software itself. Once you are comfortable with this experimental, then I can give you the battery, bulb, everything. Like this, I'll show you another experiment. Focal length of the lens. I want to find the focal length of the lens. Apparatus required. Aim is to find the focal length of the biconvex lens. Now, apparatus required: a lens, light source, screen, measuring scale, a table. It's a biconvex lens I take. Lens is here. Place the object on one side of the lens. Place the screen on the other side of the lens. Move the object here. Take a clear picture. Take the scale, measure the distance between lens and the source. This is called U. Measure the distance between the lens and the image. This is called V. Change the distance. Again measure. Change the distance further. Again measure. Take 5 or 6 readings. Calculate F is equal to UV by U plus V. Right? Take an average of that. What we can do is, through this simulation, I can teach kids exact procedure of how to do. It is not a video, it is a simulation. Before the, if I put the object here, the image will come here. If I put the object here, the image will come there. So the plane of reference is also important. This is how do you like it? I'm sure that any of you have seen this before, this kind of a simulation software before. Pilot training, aeroplane, I cannot put the pilot straight away onto the aeroplane. First put on simulator, flight simulator. Let the guy get all the control. It will be like a Jurassic Park ride. Let him get that knack, then put that person on the real flight. Otherwise, Sivagasi rocket. It will be, that guy will drive it in a wrong way. Right? In cold countries, ice will be formed on the road. Snow will be there on the road. Police and the army have to operate on that. Driving vehicle on an icy road, on a snowy road, on a curvy road, before they put that person onto that border control or emergency control, this guy has to do simulation, practice on simulators. Then there will be a field test. Then there will be reality. Firefighters, same way. Now I'm telling you the next thing. The reason why I'm telling you all these reasons is procedure, step by step operations. The way you do, I have to do this, I have to do that, I have to do that, I have to do that. That step by step sequence is very, very important. You cannot ignore that. You cannot jump the steps. Without anesthesia, if the doctor is doing the surgery, that's it. Doctor. Software also same problem. You will have an issue. The world is going to a different direction now. Okay. Is a company called Skillvary. Okay. Verify the skill. This is also very, also in Tamil. It has a different meaning. They named it in such a manner. They do augmented reality, virtual reality, and extended reality. They have a welding simulator software. I'll show you. They have a welding simulation software. You will be given something like this. There will be a table. When you hold something like this, there will be a small electronic, like a this Xbox, right? Game players or Sony game players. They'll give this. They'll put you all these goggles. You'll have earphone, everything. When you see through that, you will see like this, right? And when you see through this, you can choose what is the argon or what is the thickness of the flame, everything you should get. Choose everything. This is how they will do. This is not a welding rod. This is a simulator. This is a simulator, audio video reality simulator. And this is how when they move it, okay? You just run it. See, look at that. This is like a welding a plate. Did you notice it? Bird is moving towards, this is for welding. Same way, they have a thing for spray painting. This is an IIT Madras startup. Spray painting, it is done through simulators. People are trained to paint using spray painting simulators. You can choose the paint. See the way it is painting on the right hand side. Because everywhere, car, bus, automobile, factories, everywhere, it is all spray paints. Full simulator. Spray painting software is one of the most used software in the world by Skillvery. They are so famous in that industry. Guys, world is moving towards this. Everything can be contained now in simulators. Mechanical, electrical, electronics, including chip designs are all in software simulators. First simulate, then go to the lab. Take the reading in simulator, go to the lab, do the experiment. More or less, it will be good. The software has to be perfect. So world in terms of training moves towards this way rather than blackboard and chalk piece is also important. I'm not denying that, but there are better methods to teach. Imagine things are taught, every single experiment is taught like this to you. Will it be easy for you? Do you think? Yeah. And it will be interesting. As kids, it will be so interesting. You'll be so curious to do that. The point is, the point I want to come, why should I use the AR VR? Because knowing in brain is not going to help. How you do spray painting, how you are going to do the welding. My head is like this. If my head goes too close, the fire will hit my eyes. My rod goes too good, then it become a problem. If the rod is away from that object, again it is a problem. How you do is the most important. What you do is also important. How you do is more important because that is where you are executing. You are actually doing it. And you go to the doctor, doctor, how will you do the surgery? Can you explain me? I will take the knife, I will cut like this. That's what the first step doctor says. Will you be happy with that? No. So there is a standard procedure for everything. So procedure or process or step-by-step instruction is important. It is there for everybody. A guy comes to the reception, how to receive that person? What is the first word you should tell? Good morning or good afternoon or good night? What? Right? Imagine you go to a reception, receptionist is saying, good night, sir. May I help you? Doesn't make sense. So exactly what all the steps involved, it needs training, it needs practice. That is what is test case. Step by step details is nothing but test case. Testing X-ray machine, testing a welding rod, testing a pen, testing a bulldozer, testing a missile, testing a rocket launch, testing a software, all have a common methodology. What to test, how to test, after testing, what is the result? That's it. What to test? Aim. Okay. Then there are certain finer aspects to that. Is this clear so far? Is the concept clear so far? If so, can you please raise your hands or give a reaction? Step by step procedure. Good. Now, I'm going to stop here. I'm going to stop here. You may be coming from different branches, mechanical branch. Okay. It can be anything. Okay. Any branch you may be coming in, civil, electronics, electrical. Take one of the toughest thing that you have done. I'm just stopping the screenshot. Take one of the toughest lab experiments that you have got. Irrespective of the disciplines, branches, take the toughest one. Recollect, write the step-by-step procedure that you have done for that. Okay. Now you can think of, now we are in the second week, almost third week, tomorrow, by tomorrow it will be 3 weeks ending. In 3 weeks, all I'm trying to get is read, listen, think, right. Read, listen, think, right. This is all is entire software industry, or entire industry itself is this. Listen, read, understand, right. This is very important. There is no replacement to this. Only human brain can do that. You can connect this with the soft skill training in the evening, analytical reasoning in the evening, reading a paragraph, understanding the core of the paragraph. What is the essence of this paragraph? It's all connected. If you do that well, you'll do it well also here. That's a simple aim. Now, the question is, take the toughest experiment that you faced in the last 3.5 years in your college education. For that, recollect, write what is that procedure. Okay, recollect, mentally recollect, discuss with your friends, recollect, write it, but write it, type it and keep it ready. Now it is 11:40. Okay, I am stopping the recording now.